welcome to the second day, session 10 of the Eurasian Agriculture and Natural Science Congress. In this session, we have 10 oral presentation and we have 1 hour for these presentations. And each presentation is limited to 10 minutes. And if we have any question, please note that it will be directed to the presenters in the last 10 minutes of the session. I kindly ask the presenters not to exceed these 10 minutes. And finally, I kindly ask the presenters to briefly introduce themselves for the audience and other participants. Thank you again. And now let's start with the first presentation. I want to call upon Sevil Ünal to present with her presentation entitled Post-Harvest UVC Treatment to Maintain Cold Storage Quality of Blackberry Fruits.
Hi, I am Sevil. I work Selçuk University. Hasan hocam gözüküyor mu?
Hocam şu anda ekranınızı göremiyorum.
Hemen hocam. Tamam mıdır hocam?
Şu anda alıyoruz hocam. Başlayabilirsiniz.
Post-harvest UVC treatment to maintain cold storage quality of blackberry fruits. Blackberry production increasing worldwide to meet a growing demand from consumers, especially in the fresh market. Blackberry is a fruit that has multiple valuable compounds such as anthocyanins and polyphenolics compounds that make it a highly desirable fresh produce. Moreover, they are rich nutrients such as proteins, carbohydrates, fats, fibers, and several vitamins. Blackberry is a highly perishable fruit and have a short post-harvest life influenced by the presence of fungal pathogens. Besides post-harvest life, a blackberry is also limited. They are sensitive to water loss, softening, and physical injuries. Therefore, blackberry fruits destined for fresh markets became unmarketable up 2 or 3 days when scored at 0 degree due to fruit rot and leakage. UVG treatment has been evaluated as a post-harvest treatment for fresh fruits and vegetables, including to reduce pathogen growth. Studies have shown that UVG radiation can improve the activity of defense enzyme, inhibit bacterial growth, and induce and expiration disease resistance, thus delaying the maturity and senescence of post-harvest fruits and vegetables. Post-harvest UVG treatment has the foundation to become a low-cost, low-technology treatment for reducing fruit and vegetable loss in the supply chain. The objective of this work was to select appropriate UVG application duration and to evaluate the effect on post-harvest quality attributes of blackberry during storage. Blackberries or jumbo cultivar were harvested at full maturity stage and selected for uniformity of shape, size, and peel color. The fruits were randomly distributed into 3 groups for treatments. First group is a control. The other 2 groups is 5 minutes and 10 minutes UVG radiation. Fruits were stored for up to 10 days in a cold room at 1 degree. Fruit quality attributes were performed initially for 7th and 10th day storage. The percentage of weight loss increased during prolonged storage for control, both UVG treatment duration, while the effects of treatments of weight loss was found statistically significant. At the end of the cold storage, the greatest loss in weight occurred in non-treated control fruits, while the loss volumes was obtained from 5 minutes UVC treatment. At the end of the storage, the highest total slowly solid content was observed in control by the list volume was recorded in 5 and 10 minutes UVC treatment. Decrease in the titratable acidity volume was recorded with the prolonged storage time, and the difference between the treatments were statistically significant. At the end of 10 minutes UVC trace fluids, while the volume measured in the control fluids. At the end of the experiment, pH values were for control 10 minutes UVC and 5 minutes UVC treatment respectively. During the first 4 days of the storage period, no significant change occurred in visual quality except for control, where little reduction was predicted. UVC treatment, regardless of treatment radiations, was capable of maintaining the visual quality up to the 10 day. At the end of the storage, control fluids at the lowest visual quality score, with significant difference from both of 10 minutes and 5 minutes UVC treatments. At the end of the cold storage, the highest total antioxidant activity was obtained from the fluids of 10 minutes UVC treated, while the lowest volume was measured in the control fluids. At the end of the cold storage, the highest total phenol was detected in the control fluids, while the treatments have remarkable effects. Blackberries have a short post-harvest life influenced by the presence of fungal pathogens and susceptibility to mechanical damage, softening, and water loss. UVC, known to be an effective tool and exempting the post-harvest quality of horticultural commodities, was tested and various treatment durations for effectiveness of post-harvest quality, maintenance of blackberry stored and cold storage conditions. UVC treated fruits were higher than titratable acidity and exhibited less biochemical change than the control fruit at the end of storage. UVC treatment reduced the weight loss and exhibited markedly better visual quality with greater effect than 5 minutes than 10 minutes. Considering the overall finding, this study revealed that post-harvest 5-minute UVC treatment maintained the storage life and conserved the volume marketing feature of blackberries over 10 days in cold storage. UVC irradiation may be recommended as low-cost, environmental friendly and sustainable method for exempting post-harvest quality of blackberry cold storage without significant adverse effect on produce. Thanks.
We thank Mrs. Sevil Ünal for her presentation and for using time efficiently. And we proceed to the next presentation without any question. Next presentation, I want to call upon Mr. Adis Lizallo to present with his presentation entitled as the several methods for extending the strawberry production season. Mr. Adis, can you turn on your...
Yes, now I'm here.
Thank you.
I'm starting, okay. Can you hear me?
Yes, right now we can hear you.
Okay. Dear Mr. Hassan, dear other participants, today I will present a review about several methods for extending the strawberry production season. My name is Adis Lizal and I'm a student of 19 Mayıs University, Agriculture Faculty and Horticulture Department in Samsun. Objectives of this review covers next topics: why consider season extension options, utilization of different varieties, some type of strawberry plants, environmental conditions, protected cultivation and forcing systems. The strawberry production increasing steadily in the world, but still many factors there are which limit plant production significantly. One of it is short season production. Leader in strawberry production in the world is China, following by USA, Turkey, Spain, Egypt, and Mexico. Strawberry production in Turkey is main focus is on the Mediterranean region and Ege, but also in newly time is spreading on the other parts of Turkey. 20 years ago, growers were growing 20 different varieties in one system, but now they have 20 ways of growing the same variety, as its vertical system covered like greenhouses, open field, soilless culture, and many others. Introducing low chilling June bearing varieties able to bear fruit for longer periods during the winter and spring seasons, particularly suited for southern environments, and breeding ever-bearing varieties for spring-summer production, particularly suited for northern environments, is possible. Are two ways for extending the harvest season. Strawberry production is affected by type of plants, varieties, some growing methods, climatic conditions, locations, and also growing substrate. Knowing the plant dimension and architecture of strawberry plants, entity and quality of the production, earliness and duration of the harvest period can be planned in a very predictable way. Several type of regarding to fruits bearings are June bearers, ever bearers, and day neutrals. June bearers produce crop in May and produces more total fruit than any other types. Ever bearers and day neutral produce crop in May and but more and constant fruit during summer. In recent years, utilization of day neutral cultivars increased in commercial strawberry growing because of their importance for extending production season length. Day neutral cultivars are insensitive to photo period and continue to flower as long as temperatures are between 4 and 29 degrees. Greater than 35 degrees cause the strawberry plant to stop growing. Ideal conditions for strawberry occur when temperatures are between 20 and 26 degrees. In recent years, Monterey, Albion, Seascape, San Andreas, Portola are the most popular day neutral variety. They show great potential for season extension. They can be spring planted and fruiting starts in June and continue to the fall. If they are planted in summer, then fruiting starts in fall and spring the following year. If planting is in September, then production is for April and early July, through to the fall. Strawberry varieties that will initiate flower buds when there is less than 14 hours of daylight per day are considered to be short day. Planting of short day cultivar period is July or August, flower induction and differentiation in September, October. Dormancy starts in autumn up to through the winter. The very short harvest period in the spring. The protection is set over the crop when the plants start blooming after winter. Setting fruit for a total of 10 to 14 days, and range of temperatures and humidity should be 30 degree and 50-60% respectively of humidity. There are different type of plant material, strawberry plant material, as Frigo Fresh, tri-plants, waiting beds, and each of them provides big potential of strawberry fruit production, season extension, and high yields. Protective culture. Most of strawberries are grown in the open, but plastic tunnels and greenhouses have become popular for season extension and off-season production in areas with mild winters. It is commonly used in some parts of Europe, North Africa, Israel, Korea, Turkey, and Japan. But in USA, almost 100% of the strawberry production is done in the field. Two types of tunnels, high tunnels, low tunnels, and also combination of these two is possible. Protected system have some advantage as prevent crop damage from inclement weather conditions, provide a more favorable environment for plant growth and fruiting, improve higher total yields and fruit quality, reduce incidence of insect population, enabling strawberry fruit to be harvested 6 up to 8 weeks earlier than outdoor culture. Traditional way of growing strawberry provide better adapted to U-pick, smaller investment, but there is more pest pressure, land tied longer, and less technical. In Japan, more than 90% of strawberries are produced by forcing culture. Japan is also the leader in production of strawberries using forcing cultures. Forcing culture technology involves inducing flowering in autumn by several artificial methods, as is chilling or shorde, growing plants under a heated greenhouses to avoid the induction of dormancy, keeping them in a semi-dormant state to allow continued harvesting. This technology has contributed to such long-term harvest from late November to the June. Recently, the strawberry production cycle was shortened in the forcing culture using the 60 days programmed culture with different planting dates. This system has been expanding to meet the off-season market demand. This innovative system allows late summer and autumn production with summer planting of flower differentiated fridge store plant. There are several summary of this review is there are several attempts to overcome problem with earliness and extending the season, which includes using open and protected culture, different planting materials, several cultivars and different regions, and innovative forcing techniques. Strawberry is a microclimatic crop cultivated worldwide, but its cultivars are specially adapted to the different areas. Low chilling varieties and forcing techniques advance production and prevent winter dormancy. Protection techniques extend the production from the early spring to the autumn. Under these conditions, winter production is too expensive and is not competitive with production from Mediterranean climates. Thank you for your listening.
We thank Adis Lizalo for his presentation, and we proceed to the next presentation without any question. But as I seen, our presenter Mustafa Paksoy and Amrak Mamedov are not among us. We continue the session with the next presentation. Now I wanna call upon Ümmühan Çetin Karaca or İrfan Yarımoğlu for his presentation entitled as Soil Physical Quality Effect of Land Use. Sorry, this is the wrong presentation. The effect of several fertilization on the development of spinach and lettuce plants. Yes, Mr. İrfan Yarımoğlu, this is your turn. Thank you.
Hello. Can Lizalo move the screen, please?
Mr. Lizalo.
Yes, I moved.
Thank you. Thank you.
Hello. Hello to every participant. I am postgrad student in Selçuk University. We will present today effect of seaweed fertilizer on the growth of spinach and lettuce plant. As the world population increase, the need for food increase too. For this purpose, people need to increase productivity in agricultural production. So for this most effective way or more easy way to increase productivity in plant production has been to use chemical fertilizer. But long-term and excessive chemical fertilizer application bring lots of problem with these two. We have to expand the use of organic fertilizer or organomineral fertilizers, soil regulators, microbial enzyme containing, or other similar product to increase productivity for the plant production, to improve the physical, chemical, or biological structure of the soil, or maybe protect human health. So for this, one of the fertilizer is seaweed manure, or we call seaweed fertilizer. Seaweed fertilizer is easily break down in the soil, and it contains lots of macro and micronutrients, also lots of plant growth regulators as well. In a study by Grouch et al. On the lettuce plant, it was found that increased yield and the amount of calcium, potassium, magnesium in leaves of the crop. One of other study by Verkeley, it is extend peaches shell life. He also reported that banana and mango fruits, when soaked in diluted commercial seaweed solution, ripening rate of the crops increased significantly. An extract of Ascophyllum nodosum, which is the most active seaweed, sprayed to the spinach plant, it was found that the amount of fresh weight increased. By Allright reported that leaf and soil application of seaweed extract to wheat increased its height and dry weight too. Also, Demirkaya reported the possibilities of the using seaweed extract in osmotic conditioned application on pepper and onion seeds. Seaweed extract increased the germination percentage in onion and pepper seeds and shortened the average germination period. In recent years, in order to ensure earliness and diversification in crop production, the use of commercial liquid fertilizer with organic content in greenhouse condition has become widespread. Nowadays, seaweeds are used in many countries, either as a liquid extract or direct soil application. When mixed directly with the soil, the aim to preserve soil fertility for a long time by improving the soil structure. For many years, some sea algae drained naturally from the seas to the coast were used to fertilizer in the fields. In this study, it was aimed to determine the effects of seaweed fertilizer and organic fertilizer on yield and quality in lettuce and spinach cultivation. Which method we use on this study? The experiment was conducted under greenhouse condition using a completely randomized design. A soil sample with a salty loam texture was used. Seaweed fertilizer, a solid fertilizer named Proton and obtained from the Dr. Tarsa company. Oven dried 4 kilograms of soil was placed in the first, and after which doses 0, 1 per thousand, 2 per thousand, and 5 per thousand of seaweed fertilizer were applied to. Fertilizer doses were added to the soil during the sowing. Spinach and lettuce seeds were sowed in pots, and irrigation was carried out with distilled water. After germination and development of spinach and lettuce, the seedlings were tended to the 4 plants per pot. Spinach and lettuce plants were harvested after 60 days, and the necessary measurements were made. Above ground and root samples whose wet weights were taken were oven dried at 70 centigrade for 48 hours, and oven dried weights were measured. The data obtained from the greenhouse experiment, which was established according to the randomized plot trial design, were subjected to the analysis of variance using the Minitab 16, the statistical program, and significant mean treatment obtained from the F test were separated with Duncan multiple cooperation tests. So some physical and chemical properties of the soil sample used in greenhouse experiment. The texture is sickly loam texture, pH is slightly alkaline and slightly salty class in terms of salinity. Medium organic matter, we can say, too limey, and also sufficient in terms of macro and micronutrients for the which the soil will be used in study. Some chemical properties of the seaweed fertilizer on this experiment. As can be seen from the table, the seaweed fertilizer used in the experiment is rich organic matter. The pH is alkaline, and it is the extremely salty class in terms of salinity. This fertilizer contains 1.5% organic acid as well. If you look at the research result of the spinach plant, as we mentioned before, we use 0, 1 per 1,000, 2 per 1,000, and 5 per 1,000 application into the 4 kilogram soil. And according to the result, the effect of seaweed fertilizer applied in different doses on the plant lengths of spinach showed differences, and these differences were statistically insignificant. The highest plant length was obtained from the 1 per 1,000 application, which is 11.42, and the lowest value was obtained from the 5 per 1,000 application. If you look at the root length value, it is between the highest one and the lowest one between 8.35 centimeter and 13.83 centimeter, which the highest one from the 1 per 1,000 application, and the lowest one obtained from the 5 per 1,000 application. The values were also, if you look at the plant's weight values, it is between 5.88 gram and 12.86 gram between, and the values also obtained from 1 per 1,000 and 5 per 1,000 application. So the highest one observed pots containing 1 per 1,000 seaweed fertilizer, which was 12.86 gram, and the weight of the spinach in the pot without seaweed fertilizer control was higher than the plant in the pot, which 5 per 1,000 seaweed fertilizer. The value of plant dry weight between 0.85 and 2.12 gram, as can be seen from the figure. The highest dry weight of the spinach plant was observed from the plant in the pots on which 1 per 1,000 seaweed fertilizer was applied to be 2.12 gram, and the lowest dry weight of the plant was determined in the potted plant with 5 per 1,000 seaweed fertilizer. If you look at the root weight values, it is between 119 and 2.05 gram, and the highest one applied from the control application, and the lowest one from the 5 per 1,000 application obtained. If you look at the root dry weight values, as can be seen in the figure, the root dry weight of the spinach plant varies between 0.35 gram and 0.63 grams, and this difference statistically insignificant. The highest one obtained from 2 per 1,000 application, and the lowest one applied from the 1 per 1,000 application. If you look at result of the lettuce plant, the plant lengths between 11 and 11.6 centimeters and 14.5 centimeters, and the highest one obtained from 5 per 1,000 application, and the lowest one from the control application. To the length of the lettuce plant varied between 9.08 centimeters and 7.17 centimeters, and the highest plant root length was observed in the pot applied with 1 per 1,000, and the lowest one obtained from 5 per 1,000 seaweed fertilizer rate. If you look at plant wet weight values, it is between 18.33 gram and 13.95 gram. The highest wet weight was 1833 gram measured from the 1 per thousand application, and the lowest plant wet weight was 1395 gram in the control application. And plant dry weight values between 1.98 gram and 1.4 gram. As can be seen in the figure, the highest dry weight of the plant was observed with 1 per thousand application, and the lowest dry weight was observed with control application. The root wet weight values of the lettuce plant were determined to be between 4.07 gram and 2.96 gram. As can be seen from the figure, the highest plant root wet weight was observed in the potted plant with 1 per thousand dose, and the lowest one the lowest one from the 2 per thousand application obtained. And the root dry weight values is between 1.17 gram and 0.7 gram, and the highest one from the 1 per thousand application obtained, and the lowest one 2 per thousand 2 per thousand application were obtained. Increase to the use of chemical fertilizer and environmental pollution threatens all living things as it deteriorates natural balance and food chains. As a result, consumers prefer agricultural products produced by methods with little or no toxic effects on human and other natural settings. It is known that in agriculture and especially in soil biology, seaweed is used in many regions of the world to increase yield and quality, regulate plant growth, increase resistance to diseases and pests, improve soil structure and animal husbandry. In the research, it was observed that the application of seaweed fertilizer applied in increasing dose generally supports the development of the plant, and depending on the dose, improvement in vegetative parts of the spinach and lettuce was found. This development positively influences to the root length, wet and dry weights of the above ground of the spinach. In the lettuce plant, the application of seaweed fertilizer to the soil has been determined to be significant on the above ground and root length, as well as the plant's wet and dry weights. Thank you for your listening.
We thank Mr. Irfan Yarımoğlu for his presentation. And now we have almost 30 minutes to discuss the session presentations. Can anyone have any question? Please ask. We can discuss it right now. We have time. I'm asking again, can anyone have any question? I think there is no question. So I want to thank all the presenters to make a valuable contribution to the Congress. And I wish you have successful Congress. Thank you again for your attention. Thank you.
Thank you.
Thank you very much.
Gülbanu Hanım, oturumu sonlandırabiliriz. Buradaki oturumumuz sona ermiştir. Teşekkür ederim.
Olmaz hocam. Teşekkür ederiz herkese kongremize katıldığından dolayı.